Imagine two particles separated by the entire width of our galaxy, billions upon billions of miles apart. Now imagine that if you change something about one particle, the other particle instantly knows about it and changes too. No signal sent, no time delay, just instant connection across the void of space. This isn't science fiction. This is quantum entanglement, and it's one of the most mind-bending phenomena in all of physics. Albert Einstein famously called it spooky action at a distance, and even he struggled to accept what the mathematics was telling us about reality. Today, we're diving deep into this quantum mystery that's not only reshaping our understanding of the universe, but also powering the next generation of technology. In 1935, Einstein and his colleagues Boris Podolsky and Nathan Rosen published a paper that would shake the foundations of quantum mechanics. They presented what seemed like an impossible paradox. According to quantum theory, two particles could become entangled, meaning their properties would be fundamentally connected regardless of distance. Einstein believed this revealed a fatal flaw in quantum mechanics because it seemed to violate a principle he held sacred, that nothing can travel faster than light. If changing one particle instantly affects another light years away, isn't information traveling faster than light? For decades, this remained a thought experiment, a theoretical puzzle that physicists debated in journals and lecture halls. But here's where it gets fascinating. Einstein was wrong, but also kind of right. Quantum entanglement is real, proven by countless experiments, but it doesn't actually let you send information faster than light. Let me explain how this works. When two particles become entangled, they form a single quantum system. Think of it like a cosmic coin flip. Before you look at either particle, both exist in what's called superposition, a state where they have all possible properties simultaneously. One particle might be spinning clockwise and counterclockwise at the same time. The moment you measure one particle and find it spinning clockwise, you instantly know the other particle, no matter how far away, will be spinning counterclockwise. The measurement of one immediately determines the state of both. Now, if you're thinking this sounds impossible, you're in good company. Physicists were skeptical too, until an Irish physicist named John Bell came along in 1964. Bell developed a mathematical test, now called Bell's theorem, that could prove whether entanglement was real or whether Einstein was right that there were hidden variables we just hadn't discovered yet. For the next several decades, scientists conducted increasingly sophisticated experiments testing Bell's theorem. In 1982, French physicist Alain Aspect performed groundbreaking experiments that strongly suggested entanglement was genuine. But there were still loopholes, tiny possibilities that the results could be explained by conventional physics. If you're enjoying this journey into the quantum realm, do me a favor and hit that like button and subscribe to the channel. It helps us continue exploring the most fascinating mysteries in science, and trust me, we've only scratched the surface of this incredible phenomenon. Scientists spent the next 30 years closing every possible loophole. They separated entangled particles by greater and greater distances. They performed measurements so quickly that even a light speed signal couldn't travel between the particles in time. They used random number generators from distant quasars to determine measurement settings, eliminating any possibility of predetermined outcomes. Every single test confirmed it. Quantum entanglement is absolutely real. In 2017, Chinese scientists successfully demonstrated quantum entanglement between particles separated by over 1,200 kilometers using a satellite called Messius. The particles remained entangled across this vast distance, behaving exactly as quantum theory predicted. So what does this mean for our understanding of reality? It means the universe is far stranger than our everyday experience suggests. At the quantum level, the universe isn't made of separate, independent objects. Instead, there's a fundamental interconnectedness woven into the fabric of reality itself. Particles that have interacted remain connected in a profound way that transcends our normal concepts of space and time. This isn't just philosophical speculation anymore. Quantum entanglement is becoming technology. Scientists are building quantum computers that use entangled particles to perform calculations that would take conventional computers millions of years. They're developing quantum encryption systems that are theoretically unbreakable because any attempt to intercept the communication would disturb the entanglement and reveal the eavesdropper. Quantum networks are being constructed that could one day connect quantum computers around the world in a quantum internet. Some researchers even believe quantum entanglement might play a role in biological processes. There's evidence suggesting that photosynthesis, the process plants use to convert sunlight into energy, might exploit quantum effects, including entanglement, to achieve its remarkable efficiency. Birds might use quantum entanglement in their internal compasses to navigate during migration. But here's what really keeps physicists up at night. We still don't fully understand what entanglement tells us about the nature of reality. Does it mean the universe is fundamentally non-local? That distance is an illusion at the deepest level? Does it suggest there are hidden dimensions we can't perceive? Some interpretations of quantum mechanics suggest that measurement causes the universe to split into multiple parallel realities. Others propose that the future can influence the past, or that consciousness plays a fundamental role in shaping reality. The truth is, nearly a century after Einstein called it spooky action at a distance, quantum entanglement remains deeply mysterious. We can describe it mathematically with incredible precision. We can harness it for technology. We can prove it exists beyond any reasonable doubt. But explaining what it truly means about the nature of our universe, that question remains wide open, inviting new generations of scientists to peer deeper into the quantum realm. If this video expanded your mind even a fraction, as much as quantum entanglement expands our understanding of reality, make sure you're subscribed and hit that notification bell so you never miss our exploration of science's biggest mysteries. Drop a comment below telling me what aspect of quantum physics you'd like us to explore next. The universe is far stranger and more wonderful than we ever imagined, and we're just beginning to uncover its secrets.